Welcome back, friends. For a long time, most of students, they have asked me to do a session on the quantum numbers. I know this is one among the parts of the general chemistry topic which either it's not understood by most of the students, or they are not able to answer different questions in this part of general chemistry. So before starting our discussion about the quantum numbers, I would like to introduce the ideas or what lead to the formation of quantum number. Who was the first to know about quantum numbers? Nini kilipekea tu tuna quantum number? You know, every idea which we are knowing and we are studying, it is just the creation of people. There are some people who create them, or there are some people who think deep, and then they came up with ideas. Also, kuna atomic model nyingi kama ambavyo tunafahamu. We have Rutherford. From Rutherford we have we have Dalton, which was the area. From Dalton we have Thomson, we have Rutherford, we have Bohr, and then we have Planck's quantum theory about the nature of light, and after that we have also the wave mechanical model of an atom. So all of these models tend to suggest different things about the structure of an atom and tend to modify the structure of an atom. Kwa hiyo miaka inapokwenda zidi kwenda, different models zina modify the structure of an atom. So according to wave mechanical model of an atom, this model was developed by Erwin Schrödinger in 1927. So Erwin Schrödinger, he the one who suggested who developed this model. He used the electron of hydrogen atom to describe his model. He described the behavior of electron around the nucleus by the mathematical equation known as the Schrödinger wave equation. So Schrödinger aliona kwamba electron inapokuwa ina revolve around the hydrogen atom, inakuwa motion yake ni kama wave. Remember, in a Planck's quantum theory tulisema kwamba an electron is regarded as the particle, ambapo tukasema energy of an electron is equal to Planck's constant times frequency. But according to Einstein, he said an electron, or he regarded an electron to be like a particle. Na maanisha kwamba Planck alikuwa anasema kwamba energy light imekuwa made up of particles ambazo walikuwa wanaziita kama ni photon. Particles of light ni photon, lakini particles of other energy ni quanta is the small packet carrying energy. Sasa wale wote walikuwa na suggest kama electron can behave as both as particle and also as a wave. So Schrödinger akaja na equation ambayo aliderive the motion of electron around the hydrogen atom, how it appears. Schrödinger aliderive the equation. So on the basis of quantum mechanics, Schrödinger proposed the model of an atom which considered the wave particle duality of matter and Heisenberg uncertainty principle. So Schrödinger aliconsider the wave particle duality of matter ambayo alifanya de Broglie, and also aliconsider the Heisenberg uncertainty principle. So yeye ni kama vile alifanya a collection of ideas of other people, but also aliingiza idea yake kuhusu motion of electron. So this model was also called the quantum mechanical model of an atom. So it is called the wave mechanical model of an atom, or the quantum mechanical model of an atom. And the main ideas of this model: first, an electron is considered as the three-dimensional standing wave vibrating in electric field of the nucleus. Kwa hiyo electron anakuwa ni standing wave. Tutaenda kusoma kwenye waves ya physics. Standing waves ni waves za aina gani? A standing wave inaweza kuwa ni wave ambayo inaonekana kama inaenda hivi, lakini finally baadaye inarudi tena. So kama itaenda from left itaenda right in such way, baadaye itarudi tena left, energy transferred is equal to 0. So that is the standing wave. Also, electron tend to vibrate in its orbit, and the energy which causes its vibration is the electrical attraction or the electrical attractive force. So he regarded an electron as the standing wave. And the second idea, there is no exact position of an electron in an atom, is how Heisenberg tried to suggest about the position of an electron. Again, Schrödinger says there is no exact position of an electron in an atom. Only the space in which the electron can be met with a certain high probability can be considered. And Schrödinger called this region as orbital. Orbital. Remember, orbit ni ile circular path ambayo electron inakuwa inapita, inaitwa orbit. Lakini hapa Schrödinger aliita jina orbital. Orbital. So, and hence the wave mechanical model is also called the orbital model. So hapa ndipo ambapo pia hata quantum numbers zilikuja kuanzia. The shape of orbital can be calculated from Schrödinger equation. Shape of orbital can be calculated from Schrödinger equation. Kwa hiyo Schrödinger alikuwa ndo mtu wa kwanza kusuggest kitu kinaitwa orbital. Na orbital manake nini? Orbital is the space in which electron can be met with a certain high probability. Yani in the space around the nucleus where there is a maximum or the high probability of finding an electron. In the space around the nucleus, or in the space in an area around the nucleus where there is maximum probability of finding an electron, is what we call the orbital. So about Schrödinger wave equation, you simply need to know it. There is no need to know how to derive it, and there is no need to claim it, because you will not be asked about the Schrödinger wave equation in your exam. So what you need to know is how it appears. Because the particle would be described as a wave in 1925, Erwin Schrödinger analyzed what an electron would look like a wave around the nucleus of an atom. Manake ali analyze. So he formulated his equation for three-dimensional particle, which is complex differential equation. So this is the complex differential equation ambayo people who are doing pure mathematics, they are deriving equations like this, but no need for you to know. So from this equation, here we have the Schrödinger wave function, which is this one, the Schrödinger wave function, psi, the Greek letter psi, and then we have the direction of motion of electron, if it is whether x or y or it is z. And then from there we have this dimension, which is energy. So this is total energy, which is the summation of kinetic energy plus potential energy, and V is the potential energy, while H is the Planck's constant. This H squared, the Planck's constant. So there is no need for you to know to derive or to claim this equation. Things are not tough and such, but I pass through this equation so that you know where the idea of quantum number came from. So we are saying that when such an equation was solved for a particular electron, if such an equation is solved for a particular electron, we obtain an equation that define wave function with three parameters. We obtain an equation that define wave function C with three parameters. These parameters are known as quantum numbers. Kwa hiyo kila electron, tulikuwa tukichukua electron moja tukamuingiza kwenye ile equation, yani tukaangalia labda dimension zake za x, za y, za z, tutajikuta mwishoni tunapata 3 parameters, ambazo hizo parameter Schrödinger alizita kama ni quantum numbers. Ni number kwa alizita quantum numbers. So according to this model, an atom consists of a central nucleus surrounded by electrons in the form of three-dimensional standing wave. So electrons, they are moving in a three-dimensional standing wave called the orbitals, whose properties are completely described by 4 quantum number. So quantum number, they are numbers which describe the properties of orbitals. Ambazo tumesema orbitals, they are region or in the region around the nucleus where there is maximum probability of finding an electron. So we have 4 quantum numbers which describe the properties of atomic orbitals. We have the principal quantum number n, we have the subsidiary or the azimuthal quantum number L, you have the magnetic quantum number Ml, and the spin quantum number Ms. So thing you need to note here that the Schrödinger equation gives the probability of meeting the electron at a certain distance from the nucleus. So Schrödinger equation inatupa tu probability, uwezekano wa kuikuta electron at a certain distance from the nucleus. Note that the probability is never zero, but you can talk about certain regions in space around the nucleus where the probability or the chances of finding the electron is maximum. That means from 90 to 95, that is maximum, kwamba chance of meeting with electrons in this region around an atom is maximum. And these most probable regions in space are called the orbitals. Most probable regions in space around the nucleus where there is maximum probability of finding an electron, they are called as orbitals. So what is an atomic orbital? An atomic orbital refers to the volume or space around the nucleus where there is a high probability of finding electron. There is a high probability of finding electron. Or in other words, you can say atomic orbitals is defined as the region in space around the nucleus where probability of finding an electron is maximum. So definition that is the same, just the arrangement of words it is different. Now, after knowing the definition of atomic orbitals, let's go to discuss quantum number. As we said, quantum number, they are the numbers which describe the properties of atomic orbitals. And we have 4 categories of quantum numbers: principal quantum number, subsidiary, sometimes it is known as azimuthal, angular momentum quantum number. Then we have magnetic quantum number and spin quantum number. So an electron can be described better by the study of quantum number, which are numbers which describe the characteristics of electron in the energy level. So any electron in its energy level, let's say if we want to describe an electron in a potassium atom, and this electron is present in the first energy level, we can use quantum number to describe what is the position of this electron in its orbital, or in its energy level. If I say in its orbital or in its energy level, it is the same, because the orbital is the region around the nucleus where there is maximum probability of finding an electron. So quantum number determine all what is to be known about the electron, that is energy level of an electron, shape of the orbital, and direction of spin, because electrons, they tend to revolve around the nucleus, but also they revolve around their own orbit, or they spin around their own orbit. So the direction of spin of the electron, if it's whether clockwise or anti-clockwise, is also determined by the quantum numbers, or you can know it by a study of quantum numbers. So let's start with the principal quantum number n. Principal quantum number n. Understanding of the quantum number will enable you to answer many questions in your exam, and which will increase your performance in general chemistry and chemistry subject as well. The first quantum number is the principal quantum number. Principal quantum number is the quantum number which determine energy level of an electron. Hii quantum number inakuwa inaonyesha energy level of an electron. Electron iko shell ya ngapi? So principal quantum number determine main energy level called shell in which the electron is present. It specifies the location and the energy of an electron in an atom. Hii electron iko wapi na ina energy gani? So it is denoted by n, where the value of n can be any whole number, 1, 2, 3, 4, up to infinity. So the value of a principal quantum number starts from 1 to infinity, and this value, they are positive, because we can't have the negative energy level. So as the value of n increases, the energy level gets further away from the nucleus. When n is equal to 1, represent energy level nearest to the nucleus, yani shell ya kwanza. N is equal to 2, the next energy level further from the nucleus, yani shell ya pili, and so on. So n can have integral value from 1 to infinity. N can have integral value from 1 to infinity. The energy level 1, 2, 3, 4, 5, etc. are also designated by letters K, L, M, N, O. So as we know, the first energy level is given K, second energy level is given L, third energy level is given M, and then fourth is given N. So continuing, they are named alphabetically following these letters. So the letters K, L, M, N can stand for the values of any 1, 2, 3, 4 respectively. So K means 1, N is equal to 1, L means N is equal to 2, M means N is equal to 3, and N means capital N means principal quantum number is equal to 4. And these are described by a series of shells of increasing radius around the nucleus of an atom. Thus, letter K, L, M, N and the number 1, 2, 3, 4 are interchangeably used to denote principal quantum number. So they are used interchangeably to denote principal quantum number in an atom. So because we have said the principal quantum number determines the energy level of an electron. Energy level of an electron equal up here. But also the energy of an electron can be deduced from the principal quantum number. As we know from our equation of calculating energy of an electron, energy is equal to negative 13.6 E, that is electronic charge, divided by N square. And this N is the principal quantum number. This N is the principal quantum number. So as the value of N gets larger, N square also will get larger. And the value of negative 13.6 electronic charge divided by N will be lower negative. So that's why in the first energy level, the energy of electron is very negative, or this indicates that electron is attracted more towards the nucleus. But when you are moving further from the nucleus, energy tends to increase, and finally electron will have zero energy. If it has zero energy, that means it has no attraction towards the nucleus. So energy E1 is less than E2, is less than E3, and that is less than E4. So energy increases with the value of principal quantum number N. Now let's discuss a little about the what are the either importance or uses of principal quantum number. Anyway, principal quantum number, first it specifies the energy of an electron, and the second specifies location of an electron. Energy, as we said, the principal quantum number increases, the energy of an electron increase. But about the position or location of an electron, by using principal quantum number, we know where is an electron in the first energy level, second energy level, third energy level, and etc. Now, if we want to calculate the maximum number of electrons in a shell, if we are given the principal quantum number, maximum number of electrons in a shell is given by the formula 2n square, while n is the value of principal quantum number. Kwa shell ya kwanza, which is shell K shell, which is n is equal to 1, is 2 times 1 square, which is 2. L shell ita carry 8 electron, M shell ita carry 18, na N shell ita carry 32. How this happens, we'll discuss it later in other categories of quantum number, or in some of the questions of this part of quantum number. Now let's move to the second category of quantum number, which is azimuthal quantum number. Azimuthal quantum number, I like to use azimuthal rather than other names which are used. So azimuthal quantum number, it has other names such as subsidiary quantum number, angular momentum quantum number, or secondary quantum number. So azimuthal is the best to me. That's why I prefer using azimuthal. So azimuthal quantum number had the following alternative names, ambayo ni tumesema subsidiary. Kutoka kwenye azimuthal tumesema sometimes can be called subsidiary, can be called angular momentum, or secondary quantum number. Now, azimuthal quantum number is the energy sublevel in which electron is placed and describe the shape of atomic orbital of an electron. One among the quantum number which you must understand more is about azimuthal quantum number. Azimuthal quantum number yenyewe ni energy sublevel. So tuna energy level, principal energy level kwenye principal quantum number. Tunapokuja kwenye azimuthal quantum number yenyewe tunakuwa tuna energy sublevel. Kwa hiyo tunapokuwa tuna shell, kwa mfano shell ya kwanza yenyewe inakuwa na energy sublevel 1. Shell ya pili inakuwa na energy sublevel 2. Shell ya tatu inakuwa na energy sublevel 3. But how do we know how many energy sublevel zinakuwepo kwenye shell? Tunajuaje? So that is not the thing that we guess. There are some of the formulas which we are using to know the number of energy sublevels and what are those energy sublevels in that shell. Kwa hiyo azimuthal quantum number inakuwa represented by small l. So it can only have positive integral value from 0 to n-1. Azimuthal quantum number inaanzia 0 hadi n-1. So kama n yako ni 10, maana itaanzia 0 hadi 10-1 ambayo ni 9. Kama n yako ni 3, itaanzia 0 hadi 3-1 ambayo ni 2. So we'll have 0, 1, 2, 3 up to n-1, where n is the principal quantum number. So the value of azimuthal quantum number depends on the value of the principal quantum number. You cannot write the values of azimuthal quantum number if you are not given the value of principal quantum number. So each value of L corresponds to energy of subshell in which electron is located. The subshell orbital are designated as S, P, D and F depending upon the value of L. So tukianza S, P, D, F, hizo hapo leta lazima you must claim them at the year S, P, D, F. After F tunaendelea kwa alphabet. So kuanzia hapo F, G, H, I, it is by alphabet. But for our level we are studying only S, P, D and F. So we will end at F, subshell. Kwa kwenye shell tuna shell L, tuna shell K, L, M, N. Kwenye subshell tuna S, P, D, F depending on the value of L. Subshell orbitals, or in other words orbitals, are denoted by writing the value of N followed by designation of L. So value ya L itatuambia kama subshell yetu ni S, ni P, ni D au ni F. Tutaenda kuona kwenye table hapo chini, lakini ilivyo ni kwamba value ya L tumesema inaanzia 0 up to n-1. Value ya L ikiwa 0, L is equal to 0. L is equal to 0, that is S. L is equal to 1, that is P. L is equal to 2, that is D. And L is equal to 3, that is F. Kwa hiyo kwa mfano tukitaka kuandika orbital ambayo itakuwa ni n itakuwa ni 2, principal quantum number itakuwa ni 2, lakini azimuthal quantum number L itakuwa ni 1. Kumbuka nimesema L ikiwa 1 maana yake ni P. L ikiwa 0 ni S, 1 ni P, 2 ni D, 3 ni F. So hii hapa ili tuiandike n is equal to 2, L is equal to 1, tutaandika ni 2p. Hii 2 ina maana principal quantum number or the energy level of an electron. P ni orbital, yani P kutokana kwamba L ilikuwa 1 kwenye azimuthal quantum number, L ilikuwa 1 kwenye orbital kunaandika P, kwa sababu unajua kwamba azimuthal quantum number ina describe the shape of an electron orbital, yani maana ina describe the shape of atomic orbital. Tenda kuona huko mbele P ina shape gani, S ina shape gani, D ina shape gani. But one thing you need to understand hapa ni kwamba tunataka kuandika n is equal to 2, L is equal to 1, tunaandika kama 2p. Hapa tunako hii mbili ni principal quantum number, while hii p ni designation for subshell L is equal to 1. L is equal to 1 ndo anakuwa ni p subshell. Kwa tuna table hii hapa ambayo inaweza ikatusaidia sana kujua values za n na possible values za L. Kama n ikiwa moja, possible value n-1 manake ni n-1 itakuwa ni 1 which is equal to 0. So L itakuwa sawa na 0. Hapa tutakuwa tuna subshell mmoja tu kwenye outermost shell. Tutakuwa na subshell mmoja tu ambaye ni 1s kwenye outermost shell. Kama n sawa sawa na 2, n-1 itakuwa sawa na 2 kutoa 1 ambaye ni 1. So tutakuwa na possible values of error ambaye ni 0 na 1. Kwa kwenye outermost shell tutakuwa tuna 2 subshell ambayo tutakuwa tuna 2s na 2p. Unaona hii ni outermost shell, maana yake shell ya nje. Kama n is equal to 3, outermost shell hiyo n is equal to 3, then tutasema kwamba n-1 itakuwa ni 2. Values of error inaanzia 0, 1 hadi 2. So n-1 values of error tutakuwa na 3 orbital, 3s, here is 3p, 3s, 3p and 3d. Lakini if n is equal to 4, then n-1 will be equal to 3. So error will be equal to 0, 1, 2, 3. Na kwa hizo error sasa tutakuwa na 4s, 4p, 4d and 4f. I hope up to here umeshaelewa kuhusu azimuthal quantum number. So hii subshell L ikiwa 0 ina stand for s orbital, ambao s maana yake ni sharp. L ikiwa 1 stand for p orbital, p maana yake ni principal. L ikiwa 3 stand for d orbital, d maana yake ni diffuse, and L is equal to 4 stands for f orbital, f from fundamental. Kwa hiyo hizo names it's not much for you to remember: sharp, principal, diffuse, fundamental. But what is important for you to remember ni kwamba L ikiwa 0 inakuwa s, L ikiwa 1 inakuwa p, L ikiwa 3 inakuwa d, L ikiwa 4 inakuwa f. Thus, in any main energy level, the energy of S subshell is lowest. Energy of S subshell is lowest. The energy increases in going from S to F. Kwa hiyo kama tuna subshell nyingi, any subshell itakuwa na energy ndogo, will be less than NP, less than ND and less than NF. Huyu kama ni shell labda ni 4, 4s atakuwa na energy ndogo kuliko 4p, kuliko 4d, kuliko 4f. So energy increase in this direction. That's all about the azimuthal quantum number. From there, let's discuss about the magnetic quantum number. Magnetic quantum number. A magnetic quantum number, this is the quantum number, inakuwa denoted by M O M L. Yani ni M afu ina L ambayo ni subscript. But the best way is by writing M subscript L. M subscript L is the best and the most common way which can be understood by all teachers. So this is the quantum number which describes the orientation of designated orbital. Remember, in the azimuthal quantum number, ilikuwa na determine shape of atomic orbital, but this determine orientation. There is difference between shape and orientation. Orientation ni mkao, shape ni umbo. So umbo na mkao wa kile kitu ni two objects, they may have the same shape but they may differ in orientation. Shape ikawa ile ila orientation ikafanyaje ikadifa. Vitu vile vinaweza kuwa vina shape moja ila mkao wake vikawa vina tofautiana. So orientation ni mkao. It is represented by MOML. It differentiates orbitals that have the same shape and energy but have different direction when they are subjected to magnetic field. Kwamba tunaweza kuwa tuna orbital mbili ambazo zina shape moja, zina energy moja, ila tu kiziweka kwenye magnetic field orientation yake inatofautiana. Ndio maana tunaita magnetic quantum number, because when you subject an atom in magnetic field and then you observe it, utaona kwamba orientation of these orbitals tend to change. So magnetic quantum number is restricted by subsidiary quantum number L. Quantum number ya kwanza principal, ya pili ni subsidiary au azimujo. Value ya azimujo inategemea principal alikuwa ngapi. Lakini tunapokuja kwenye magnetic, value ya magnetic inategemea azimujo alikuwa ngapi, au value ya magnetic inategemea subsidiary alikuwa ngapi, ambaye subsidiary na azimujo ndio yule. So magnetic quantum number is restricted by subsidiary quantum number L, and it is represented by 0, positive and negative integers. That is, inaanzia kwenye negative L, inapita kwenye 0 to positive L, inaanzia kwenye negative L ambayo L ni azimujo quantum number. Negative L inapita kwenye 0 inaenda kwenye positive L. That is the value of magnetic quantum number. Thus, for a given L value, there are 2L plus 1 values of M. 2L manake zile za negative na za positive zitakuwa ni 2L. Then plus 1, hiyo 1 ni nini? Ni 0. So total magnetic quantum numbers is equal to the total number of orbital of that type and is given by 2L plus 1. So for any value of L, to get the total magnetic quantum numbers, or to get the total number of orbitals. Kumbuka kwenye azimujo tuko naangalia shape of orbitals, but in magnetic quantum number we can get the total number of orbitals and even the total number of electrons. So to get the total number of orbitals ni 2L plus 1. For example, kama principal quantum number yetu alikuwa ni number fulani, let's say atumjui, then azimujo quantum number akawa ni L. So the magnetic quantum number itaanzia negative L, itafuatia negative L plus 1, itafuatia negative L plus 2, then toka hapo tutaenda na hizo namba mpaka tufike 0. Regardless huku tumeanzia ngapi, ila mpaka tufike 0. Tukifika 0, huku zitaanza kutoa, huku tutakuwa tuna plus mpaka ifike 0. Huku hizi positive tutakuwa tuna minus mpaka ifike tena value ya L. Kwa kama L huku ilianzia negative 5, tutatoka negative 5, negative 4, negative 3, negative 2, negative 1, 0. Toka hapo tunaanza tena kupungua 0. Tukitoka 0 tunafuata 1, 2, 3, 4, 5. Kwa hiyo value iliyokuwa huku negative mpaka ije ipatikane huku positive ndio inakuwa tumeshaandika magnetic quantum number zote. Kwa hiyo kama L is equal to 0, then 2 plus L, 2L plus 1 itakuwa ni 1. Kwa hiyo kwenye L is equal to 0, kumbuka L is equal to 0 manake principal quantum number n hapo ilikuwa ngapi? N ilikuwa 1. L is equal to 0 manake ni shell ya kwanza hiyo. L is equal to 0, that means we will have only one subshell, we will have only one orbital, kwa sababu magnetic quantum number inadetermine orbital, sio subshell tena. Subshell ni kwenye azimujo, huku ni orbital. L is equal to 1, tutakuwa tuna only one orbital which is S. Na kama unakumbuka tulisema L ikiwa sawa na 1, L is azimujo quantum number. If L is equal to 0, then tunakuwa tuna subshell ambayo ni S. Only one S orbital. S is subshell. S ni subshell. Katika subshell yule ndani yake kuna vyumba ambamo electron wanakaa, ndio zinaitwa orbital. So okay, anyway, don't confuse the ideas. Sio kusema kwamba mmeshasema orbital is the region around the nucleus where there is maximum probability of finding an electron. Yeah, that is the definition of atomic orbital. Lakini kama tunachora labda electronic configuration, tunaweka vibox ku represent orbital. So orbital the area around the nucleus where there is maximum probability of finding an electron. Lakini tunavyokuwa tunachora diagram fulani au structure fulani, tunaweza tukaweka vibox. Vile vibox vinakuwa vina represent orbital, vinakuwa vina represent kitu kile kile. Kwa hiyo sasa kwenye hii energy level ya kwanza tunakuwa tuna only one S orbital which can accommodate a maximum of 2 electrons kama ambavyo tena kusoma kwenye electronic configuration. Lakini L ikiwa is equal to 1, then 2L plus 1 is equal to 3. So L ikiwa is equal to 1, implying that there are 3p orbitals, and that's what happen in real life. Tuna orbitals za p tatu, ambazo katika orbitals za p tatu tuna px, tuna py na pz. Px, py na pz zinaitwa px, py, pz kwa sababu ya different orientation, mkao wake ni tofauti. Lakini if L is equal to 2, then 2L plus 1 is equal to 5, implying there are 5d orbitals. Sababu L ikiwa 2 maana yake hii ni d subshell. So kwenye d subshell tutakuwa tuna 5 orbitals, and this we have a dxy, dxz, dyz, dx square minus y square and dz square. Tenda kuona kwa mbele na shape zake. So for your level, what you need to know is about the s yenyewe, kwa sababu iko moja, so haina designation yote. P we have px, py, pz. D we have dxy, dxz, dyz, dx square minus y square and dz square. Lakini if L is equal to 3, then 3L itakuwa sawa na 7, yani tutakuwa na 7 f orbitals. Tenda kuona zaidi kwenye kuchora electronic configuration. So the number of orbital in S sub energy level or S subshell ni 1. Number of orbital in P subshell ni 3. Number of orbital in D subshell ni 5, na number of orbital in F subshell ni 7. F subshell ni 7. So if n is equal to 1, L is equal to 0, m itakuwa sawa na 0. Kwa nini? Kwa sababu value ya m inaanzia negative L through 0 to positive L. So total of one orbital in n is equal to 1. Lakini if n is equal to 2, L is equal to 0. L if n is equal to 1, L is equal to 0, m atakuwa sawa na 0. Maana yake hii ni 1 s orbital. Lakini L, kumbuka huyu n yakiwa 2 atakuwa na error ambayo ni 0 na error ni 1. Error inapokuwa 1, m atakuwa negative 1, 0, positive 1. Hizi ni 3p orbital. So 1 jumlisha 3 tunapata 4. Unaona? Hapa tulivyokuwa na n is equal to 1, tulipata total number of orbital ni 1. N is equal to total number of orbital tunapata 4. Lakini if n is equal to 3, manake L can be 0, can be 1, can be 2, because the value of errors inaanzia 0 to n minus 1, yani 3 kutoa 1 ambayo ni 2. So L is equal to 0, m itakuwa 0, 1s orbital. L is equal to 1, m itakuwa negative 1, 0, positive 1, 3p orbitals. And L is equal to 2, m itakuwa negative 2, negative 1, 0, positive 1, positive 2, 5d orbitals. So finally unapata total of 9 orbitals in n is equal to 3. Kumbuka hapa tunazungumzia kwenye energy level moja tu, n is equal to 3. Kama huyu atom wana energy level nyingine za ndani, n is equal to 2, n is equal to 1, hizo hatujazihesabia. So tunachokisema ni kwamba in absence of any external magnetic field, all orbitals or all electrons having the same value of n and L but different value of m, they have the same energy. Kama hatuna external magnetic field, electron zenye value ya n na L moja, yani principal quantum number pamoja na azimuisho quantum number, but they have different values of magnetic quantum number, they have the same energy. And such orbitals having equal energies are called degenerate orbitals. Na electron ambazo zinakaa kwenye orbitals kama zinaitwa degenerate electrons. For example, all 3p orbitals px, py and pz, all 3p orbitals px, py and pz have equal energies. However, in presence of external magnetic field, their energy will differ slightly. Now how the energy of these 3p orbitals px, py and pz will differ slightly in magnetic field, how will they differ slightly? The explanation for this, we are saying that the moving electron possess angular momentum. Kama unavyofahamu kuhusu angular momentum of an electron is quantized from the Bohr atomic model. So the angular momentum of an electron, they possess angular momentum. This produces a small magnetic field. When external magnetic field is applied, the two magnetic fields interact and the electron in a given subshell orient themselves in a certain preferred direction relative to the direction of external magnetic field. This changes their energy slightly. Kwa hiyo orientation, ule mkao wa magnetic field tukiwa tuna external magnetic field unabadilika. I mean mkao wa atomic orbitals tukiwa tuna external magnetic field unabadilika. Na mkao wa atomic orbitals ukibadilika, that means their energy changes slightly. So the number of different orientation which become possible depending upon the value of L, and the direction of orbital relative to magnetic field is determined by the value of M. And from this table unaweza kuona S subshell anakuwa na L sana 0, M sana 0, 1 orientation. P subshell L sana 1, M sana -1, 0, +1. 3 orientations, Px, Py and Pz. But D subshell in L is equal to 2, M is equal to -2, -1, 0, +1, +2. 5 orientations, dxy, dxz, dyz, d square minus y square, dx square minus y square, and dz square. Now from there we can touch a little about the calculation of the total number of orbitals in energy level. Total number of orbitals in energy level. So from the above calculations which you have calculated for the energy level number 1, number 2, and number 3, to get the total number of orbitals, it is very easy. So from the above calculation, for n is equal to 1, total number of orbitals tulipata 1. For n is equal to 2, total number of orbitals in 4. And for n is equal to 3, total number of orbitals ilikuwa 9. Looking at these numbers, you observe the total number of orbitals in nth energy level is given by n square, where n is the main energy level, which is the principal quantum number. And one thing also need to note from this part is about the definition of degenerate electrons. Are two electrons having the same value of n and L but with different values of M, L, B. So they are called as degenerate because they have the same energy. Now, let's finalize our discussion by discussing about the spin quantum number. MS. MS is the short form which is commonly used rather than S. So about spin quantum number, value ya spin quantum number haitegemei quantum number nyingine yote. Yenyewe ina determine direction of spin of electron in its orbit, whether electron na spin clockwise au anti-clockwise. So spin quantum number MS is the quantum number which gives the direction in which electron are spinning in its own orbit. The electron in an atom revolve around the nucleus and also spin about its own axis, kama ambavyo Earth inafanya rotation pamoja na revolution. Rotation about its own axis and revolution around the sun. This is rotation of electron about its own axis is described as spin quantum number. It is denoted by MS and can only have two values, ambazo negative a half and positive a half. Negative a half ambao ni spinning of electron anti-clockwise, na positive a half ambao ni spinning of electron clockwise. Kwa hiyo the value of a principal quantum number, the value of spin quantum number inaweza ikawa tu ni mbili, ni negative half au positive half. So ikiwa Ikiwa ni negative half, manake tunaweka hivi, kamshale kanakuwa kanashuka chini, electron na spin anti-clockwise. The value of ms ikiwa ni positive half, that means electron ina spin clockwise. So cha muhimu kwenye electronic configuration, aka ka arrow tutakatumia sana, aka ka arrow tutakatumia sana, so it is very important wewe kuziona hizi arrow vizuri kabisa, kuziona hizi arrow tutazitumia sana kwenye electronic configuration. So kwenye electronic configuration ndo maana hauwezi kuwa una arrow mbili zote zimeenda juu. Arrow moja lazima iende juu, moja ishuke chini. We shall see the principles of writing electronic configuration. So since electrons exist in pair, ms is always denoted as positive, yani plus or minus a half. Plus or minus a half manake hiyo ni 2 electron. Hapo ina represent 2 electrons. So the value of spin quantum number does not depend on any of the 3 quantum numbers. Does not depend on any of the 3 quantum numbers. So application of quantum number, kwanza inatumika katika determine maximum number of electrons in a shell. Hata kwenye atom zima unaweza calculate. Lakini pili, quantum numbers zinatumika katika kudetermine electronic distribution au electronic configuration. Kwa hiyo kwa kutumia quantum number, concept za orbital tunazitumia kwenye electronic configuration. Kujua shell ya kwanza inaweza kuwa na electron ngapi, shell ya pili na electron ngapi, na etc. So about electronic configuration and the principles of electronic configuration, they will be discussed later. And also about the solved questions in this part, they can be discussed later if we will get time. But if we will not get time, yeah, I would like to advise you to find these notes. These notes in modification year 2021. Now, when I taught general chemistry in 2020, I used different notes which are not this one. So I have done a modification, and these are the best as compared to the previous one. They contain everything, making sure a student is able to perform all categories of questions, and finally to have a best performance in advanced chemistry. Let me wish you nice studies. If you need anything from me, I hope most of you know my contacts. You can contact me if you want to learn anything from me. And now I starting the program of Pre-Form 5. You can join me, and then you can study many things and to enjoy a lot. Thank you, and let me wish you nice studies.